I didn't post a recording of section 1.7, but I will post that today because I recorded 1.7 in my other class yesterday, so I'll go ahead and post that in the additional videos folder that's down towards the bottom. Today's session will be recorded right here in Blackboard. Just remember you can look in either place when you're looking for a video. Either right in Blackboard Collaborate, you push the menu button and go down to recorded sessions. And if it's not there, then you just go down to the bottom of your Blackboard page and there's a folder that has additional lecture videos in it. That's for when I forget to record in your class. Okay, so today we're going to be on section 1.8. That is the last section of the chapter. So today is the 10th. Don't forget, the testing window opens up on 9/17 and remains open through the 20th. So you want to be making sure that you're getting the portfolios done and that you're giving yourself enough opportunity to do what's most important, only because it's the biggest part of your grade, is to study for that test, to do any kind of practice test that's been made available to you. Do it right there in Alex, and make sure that, if you have any questions, that come to tutoring. I do a lot of tutoring during the week, and you can show up to any of those sessions. Anytime I have a session, I send out an announcement and an email to everyone announcing that I am now online and that you are welcome to attend. So make use of that. And if you can't make use of my office hours, there's the ASC lab, nice presentation that we had the other day, how to use it. And there's also SmartThink, which is tutoring that's offered 24 hours a day, 7 days a week with a virtual tutor. All three of those icons to access tutoring are right there in your Blackboard shell, and I think I clumped them all together in one section, so everything's super easy for you to find. Do you have any questions for me before I go on to what I'm going to do? Okay, so I think what I want to start with, again, just because there's some people that are, maybe not understanding some of the concepts and possibly don't understand that you can ask a question while you're doing the end of class activities. You can ask me. I'm getting a little bit better at popping into your groups. I wasn't quite solid on how to get the audio to work, but I think I have mastered that. So when I pop into your group, when I do put groups, I don't know that I'll do that today, because probably all I'm going to do today rather than an activity is I'm going to go over the activity that we just did. Notice that your activity grades are going in as soon as you take them. They're in the grade book. So if you have been accumulating zeros because you're not attending class, you might want to do something about that, like attend class, because they count for 5%. But anyway, they are located all the way in the last columns of the grade book. Let's see. So I want to go over some of those problems, which was a review of everything we've done so far in 1.1 through 1.7. That was the last activity that we did. Okay, so let me skip over to, I'm going to have to go back and forth between Socrative and my document camera. Let me call up Socrative. Hold on for a second. Okay, I'm going to share my camera with you, show the problem first. Please feel free to interject at any time when I'm doing a problem if you have additional comments or questions regarding the problem. This is just so that I can serve everybody in the class at all levels. So if you did get these right, please excuse me while I go over them for the people that did not get them right. Okay, so let's see. I'm going to share my screen from tab. Let's see. This is going to be Socrative. Okay, so right now you should be seeing the very first question there. It says there's 120 pies in the bakery with 30 of them being blueberry, and then the question is all about the blueberry pies. What is the percentage of blueberry pies? So if 30 of them are blueberry, and you know that whenever you do a percentage, it is the items of interest, those being blueberry pies, out of the total. So the work for that would be, let me switch over to my camera. And let's see, there's another question here as well. The other question, although I stopped sharing my Socrative screen, but I can just say it verbally. Not only were you supposed to find the percentage of blueberry pies, but you were also supposed to create a degree graph, and just basically not create a whole graph, but just tell me how many degrees would be devoted to blueberry pies. So I'm going to do both of those things and give you both answers. I'll get this going in a minute. Okay, here we go. All right, so in number 1, there was 30 blueberry pies out of 120. You are most welcome to put that in your calculator, and in fact, I'm sure most of you are. But all you're doing is going 30 divided by 120. That turns out in your calculator to be 0.25, which the first question was, what is the percentage of blueberry pies? So you have to slide that over 2 places. That's the same thing as multiplying by 100 for those of you that are used to doing that. So 25% of the pies were blueberry pies. Next question, same problem, was how many degrees should you devote if you were going to make an entire circle graph? How many degrees would be devoted to blueberry pies? So kept trying to remind you, that's why I keep putting this inside of your activities. Use the decimal, not the percentage, when you're doing degrees. So it's 25%, but in decimal form. Of means multiply, a total of 360 degrees. So this answer gives you that. And when you put this in your calculator, you end up with 90 degrees. So this was the percentage answer they asked. This was the degree answer that they asked. All right, had to get a calculator. All right, now I got a calculator. Let's go to the next question. Okay, next question. You can see the answers there, besides me showing them to you. Okay, if you were going to create a circle graph, approximately how many degrees would be devoted to drama movies? Okay, so if you look on the little legend that they have here where they show you the colors and they speak about what each color stands for, it says drama is in dark purple color. There's a 14% right there, so I'm going to write that down. And I just want to know how many degrees. Okay, so switching back over to the camera. Okay, So this is the information I got right off of the circle graph. Again, just want to keep reiterating that when you're going to find degrees, it is the version of the percent times a total of 360 degrees, so that you are and you get 50.4 degrees. If they do happen to ask you to round it to the nearest number of degrees, this means you're rounding. That's just the symbol meaning I approximated. This is closer to 50 degrees than it is to 50.4. So let's just go and see what kind of answers were offered there. Okay, so in this particular problem, yes, we did round to the nearest degree, and all of these were to, there were no decimals, so that was choice A. Okay, next question is number 3. Add the terms if possible. Minutes and camels, they are not the same unit, and there's no way of converting minutes into camels, so that is not possible. Okay, number 4, add the terms if possible. Yes, you can add these because they both contain the same variable, x, the variable's letter, and the power on the x's that you see in each of these terms are both x to the first degree. So when the base and the exponent is the same on the variable, then you can actually put them together by combining the coefficients. So that was 17x. I would show you the work if there was much to do, but there isn't. So you can go directly to the answer. Now, with regard to how much work you should be showing me, please don't say on the test because I will mark down. You're going to scan all of your work when you take the test, and you are going to Dropbox it to me within 15 minutes of taking the test. I need that work right away as soon as you get done submitting your final answers. Your grade will be reduced if you don't have adequate work. So please don't say, I didn't know how to show my work, because I'm demonstrating for you how to show your work on a daily basis. Even things that you put in the calculator, you're going to put them on paper. Now, like in a problem that I just did, where you could that's just too easy when you're adding 3x and 4x or whatever we just added. We added a couple of things. It's fine if you go directly to the answer for something like that. For the problem that we did right before that, where the answer was not possible, okay, you don't have to show the work. Maybe you want to write a sentence that minutes can't be converted to camels, but you could also just say, not possible. The terms are not like terms. They're unlike terms. You could say something like that. So some problems you can just answer in the form of a sentence, but not really show any work. So I understand when you don't have work for something like that, but for most of these, you can show work. Okay, moving on to number 5. I did get quite a few questions on these interest problems. They always seem to pose a problem, and I think it's because students are not used to using formulas, and you have to use formulas when there's a formula that goes with the problem. So in number 5, you're seeing the information there. It says balance of your bank account is 178.89. You do a debit of 312 and a return of an item that cost you $27. So I'm going to go to my paper in a minute, but let me jot these numbers down. So this is number 5, and you can definitely show work. You start off with a balance of 178.89. Let me jot that down. It says you do a debit. Debit means that money gets subtracted, as most of you well know. And when you return an item, that money goes back into your account. It gets added to your account. So I'm going to add in 27.39. Switching back over to my camera. And there you go. Concerned about showing work? That's exactly how you would show the work, that you did a debit. Debit means you subtract the money from the beginning balance, which was this 178.89, And when you return an item, that money gets credited back to your account, and then you put it all in your calculator. So when you enter this, you would enter the top number, 178.89. You would subtract $3.12, and then without pushing enter, you can push enter just once at the end, add in the 27.39. I mean, you can push equal in the middle, but I just do it all at once. And there's your answer. $203.16. Just a little banking problem. Okay, going back to Socrative, pick up that next question. Okay, next question on the review. This is number 36, where we started to get into the interest problems. So the first one, you got to look for the phrase simple interest or compound interest. Look for one of those phrases, because depending on the phrase, that helps you select the correct formula. You can make a note card. You can have a 3x5 note card for each test, and you can put the formulas that we have come across as we've done problems throughout the work. If you've been taking notes right alongside of me, that was very highly suggested that you do that using the same outlines that you see me giving you the notes on. Those are right in the lessons note packet, but those are excellent. If you're filling them out right alongside of me, they're excellent for helping you get through the end of class activities, and they're excellent for looking through those notes for any given chapter and picking out the formulas that I've used. So if you want to get yourself in an organized state of mind for going to college and actually graduating from college, you have to pick up habits that successful people pick up. And one of those things is attacking the content, the way you're receiving the content, in an organized manner. And certainly that would not be just trying to memorize it as I go through it, especially if you think that your skills are lacking in mathematics. Maybe you have forgotten a lot of things. So please don't just try to commit everything to memory, because even the students that get the higher grades do a lot better when they take notes, use the notes to make the note card, and use the notes to do the end of class activities. Those are all things that will help you grab maximum points, and they're good habits to pick up. Because next class that you go into, you will go into a traditional setting where you now have a book and a lecture. This class used to be collaborative. We did it all collaborative. We would be doing problems together in groups. And so that's how the students would learn it. It never was really a lecture. The only reason it's a lecture now is because we had to switch to synchronous because of all of this pandemic situation that's going on. But next class, it's definitely going to be offered with a book and a lecture, and so it's good for you to pick up good habits of taking notes. And the next class is full of formulas, way more than this class, so you want to start those habits in check. Anyway, on to number 6. So I see the phrase simple interest in the very first sentence, so I'm going to write down the simple interest formula, which is principal times rate times time. I will move over to my camera. Let me just grab this information. So let's see, it's 2,000 for the principal. This says that the rate is 6%. And then it also says that you want to know how much is in the account after the 3rd year. Now wait, let's see. Let me read it more carefully. How much do you have in your account after the 3rd year? Remember, simple interest formula only gives you interest. It doesn't give you the entire amount. So I want to make a point of that, which is why I wrote this as part of the question in Socrative. The interest formula for simple interest only gives you the interest. You have to do addition to get the entire amount, which is what this question is asking. It wants to know what is the entire amount. Okay, I'm going to switch over to my camera. So stop. Okay, here's the information that I just grabbed off of that page. Everything I need to get this problem done. So we're going to do the interest after 3 years. You don't have to hang the 3 over there. It's just a little notice to show what I'm doing. The principal is the $2,000. The rate always has to be as a decimal, no matter what kind of problems you're doing with rates. So there's your rate, 0.06, and the amount of time is 3 years. You're going to go put that in your calculator. It's going to be 2,000 times 0.06 times 3, and you get $360. However, if you give this as the answer, you're not answering the question. The question says, what is the final amount in your account? So make sure that you read the question carefully. Final amount would be what you put into your account originally, what you walked into the bank with the day you opened up the account, plus the money that the bank has paid you for being their loyal customer. So now when you add these up, it's $2,360, and that is your total amount. Hopefully you're seeing what you did wrong, and because you can probably still remember how you answered these questions. And if anybody ever wants to go over their Socrative quiz individually, like they want to see which ones they did wrong, you can just come during my office hours. Other students do this. They will come to me with either their Socrative quiz, or say, they'll come to office hours and say, I want to go over my Socrative quiz and see exactly which ones I got wrong. You should probably keep whatever work that you're working out as you do the Socrative quiz, because then when you come to me during office hours, you can look at what you did as opposed to how I'm showing you how to do the problem when we identify a problem that you've done wrong. And that would be a good way to figure out where are you going wrong, if you're going wrong anywhere. But you know what your grades are. If your Socrative grades are good, then maybe you don't need to do that. But if your Socrative grades are poor, that means you're not asking anybody in your group for help. You're not asking me for help, although both of those things are allowed while you're doing an activity. And you're not coming to tutoring. So make sure you do something about your situations to make them change if you don't like the way they're coming out. Let's go to number 7. Let's see. I'm going to go back to stop. Okay, moving on to this one, which seems to be even more challenging for students, which is the compound one. 3 or 4 people asked me about that one. So this says, how much will you have in your account after the 3rd year? The account pays compound interest. So I'm going to, as soon as I see that, I'm going to write the compound interest formula. And I'm going to write the numbers that they were given, but they're the same numbers, $2,000, 6%, and a rate, that was the rate, and a time of 3 years. Okay, switching back over to the camera. Okay, so this one asked for compound interest, so I wrote the formula down right away. Notice that this one doesn't start with an I for interest, it starts with an A for amount. That means final amount. This one actually gives you a combined amount. It combines the amount that you originally started the account with the interest that you're earning. So this is a combined amount, final amount. Put your 2,000 in. You don't have to put it in parentheses. I don't want you to think that you have to do that, but here's how you show the work for this. You would put 2,000 in for your principal amount. Then it's 1 plus the rate. Remember, rates are always used as decimals, and the amount of time is 3. You might want to clean this up a little bit just so you don't have to put all this plus in. Maybe just combine these two numbers. This will be 1.06 first. You could always get your calculator to do that if you do it in your head. Now feed it into your calculator. Okay, so here I go feeding it into my calculator, and I'm going to feed it in just like it looks on the paper. 2,000. I'm going to open up a parenthesis, just touch the key that has the parenthesis symbol on it, which is right there. You have parentheses on your calculator also. Feed in the 1.06, close the parenthesis, pick the one that goes the other way. Now take what's inside that parenthesis and raise it up to the power. So you need to find your power key. Mine is a little caret key. Put the power on there. Press enter or equals, whatever your calculator has. Mine has enter instead of equals. And the amount is 2,382 and 3 cents. You stop it right at the second number. And that is the total amount in your account. So the simple interest one, which was problem number 6, after 3 years, I think it had 2,360. And this one has slightly more because compound interest accounts, they grow more rapidly than a simple interest account. So that's why you end up having more money by the second and the third year and every year after that. Okay, moving on. Let's go to back to the next question. Next question was, where is -3, -7 located? I mean, you could do this with no work, but for those of you, and I did see people in the chat box saying, where's -3, -7 located? Again, this is why I'm going over this. So just so I mean, it's hard to get other problems right if you don't know, if you can't plot a point. So just as a refresher, let's go in, share camera. Okay, just to review, this little quick XY axis, this is the X, this is the Y axis. All the numbers over here are positive, like this would be all the way up to +4. You can put numbers on all of them if you want to. Everything over here is negative. This is your Y values that are positive. And these are your Y values that are negative. So if you wanted to do something like -3, -7, you would go, you always do the X value first, although you can do whichever one you want first, it really doesn't matter. Go out to -3 on the X axis, so that would be 1, 2, 3, and then go down to -7 in the Y direction. Y direction is when you move up and down. This is when you either move left or right. Okay, that's for your X value. This is when you move up and down. And I know that seems very basic to some of you, but there are some of you that have been away from the math for quite a while and may have forgotten stuff like that. Okay, so this point would be out to -3, down to -7, and then you label it. Okay, so as far as what quadrant it is in, then you have to just remember that the quadrants are numbered like this. This is quadrant 1, and then they get numbered going this way, counterclockwise. So this is quadrant 2, this is quadrant 3, this is quadrant 4. So maybe some of you knew how to plot the point, but then possibly didn't know that the quadrant was called quadrant 3, because maybe you thought that they got numbered this way. So some people may have gotten it wrong just because of that. They're numbered counterclockwise. Okay, moving on. Enough of that. Okay, so let's see. Next question was number 9. Consider the scatter plot diagram at the top of page 60 in your book. Name the decreasing intervals. Okay, so let me get to that page. Everybody should have a page and have a book, and if you don't, then I showed you how to use the virtual book so that you can answer questions when we are doing any kind of activity. Okay, moving over to the camera again. I'm going to show you page 60, point out the answers to you. Okay, so this was the diagram at the top of page 60. You're looking for the decreasing intervals here, and I will record those as best I can. So it looks like whenever the graph is falling, that's called a decreasing portion, which is what this question was about. So it appears that right at the year 1992, it began falling, and it stopped falling right at the year 2000. So from you got to look at the numbers underneath the falling portion. This whole thing is a decreasing portion. So from 92 to 2000, I'm just going to record these as I go along. And then let's see, here we're going up, up, up all the way there, and then we start falling again right there. Here it's level. So the falling starts right here, and it stops right there. So the point that's associated with this looks like about 2003, and then this point right here looks like about 2007. I'll just have to see what answers closest to this, but I think I'm pretty much gauging it properly. Okay, and then right about here, from here to here, it's level, so that's not considered a decrease. And then here we go. We start climbing upward again. Even up here, we are still going up. From here to here, you're still going up. So right about here, it starts climbing, and then it stops climbing right there. So all of that is considered an increasing portion, but we're only looking for decreasing portions. So here is a decreasing portion. This portion appears to be from 2010, right there is where it starts falling again, 2010 all the way to 2015. And then we'll see what looks the closest. So that was something that I did as a book problem when I was spiraling back to the book problems. I did that in a previous lecture and then included it in the activity again. Okay, so I'm going to switch over to Socrative again. Chrome, Socrative, share. Now let's see what answers look the best here. Okay, 92 to 2000, 2003 to 2006. And then, I mean, it's a giveaway that it's this answer because there's 3 falling pieces, and this is the only answer that had 3 intervals. These are called intervals. From 92 to 2000, it was falling. 2003, I guessed 2007. It looked like it was that, but it was 2006. And then from 2010 to 2015, so that would be answer C. Okay, moving to number 10. What is the probability of drawing a diamond from a standard deck of cards? Is this theoretical or empirical probability? The thing that is missed most heavily, and again, these are questions that I put in your activities, the things that are missed quite a bit, like the thing about the degrees, the thing about the compound interest, the thing about is it theoretical or empirical. Those are the things you're going to see keep popping up in the activity. Get you to understand it by the time you take the test. Okay, so like this one right here, notice that you can do this problem without going into the general population and recording results every time. You could literally figure out what this probability is without collecting any kind of data on a table. So therefore, this is theoretical. When you're collecting data on a table, like you're doing an experiment repeatedly, you're doing it over and over and over again. So it'll say something like you're doing you're performing a certain action 200 times. You're performing a certain action 500 times, and you're recording the results that you get each time you do this particular action. That's an experiment. You're doing some kind of action repeatedly, collecting the results in a table, and then doing the probability. We're not doing that here. When you're not collecting any results in a table, it's theoretical probability. If you can remember that, data collected in a table or a bar graph is called empirical probability. So as far as this question goes, it's theoretical. And as far as the probability itself goes, just how many diamonds are there? Diamonds is one of the suits in a deck of cards. There's 4 suits, and in each suit there are 13 cards. So there's the suit of spades, clubs, diamonds, and hearts. So 13 out of 52. 13 out of 52, and then it reduces to 1/4 if you put this in your calculator. The TI-30s will reduce also. Mine reduces probably with a different key than you have. So I don't have a TI-30, but let's see. So mine would just go back to this. So that's choice A, 13 out of 52, it reduces to 1/4. You can see the answer there, and this is called theoretical because there was no table of collected information. Okay, going to number 11. In problem number 11, now here you're doing a particular action many, many times. You're repeating the action and you're recording what is happening each time you do the action. It says that someone goes and rolls a die, that's the action you're performing, 100 times. And they collect the results in a table. You're doing an experiment. You're collecting data for an experiment. And it says that the number 5, they recorded, the other numbers that were rolled. But with respect to this question, you only need to, the question only concerns the number 5. But in the table, there would be information about how many times did a 4 get rolled, how many times did a 1 get rolled. So it would look something like this, even though they don't talk about all the other numbers. The minute that you see they're repeating the action over and over again and collecting the results in a table, that is empirical probability. So like for instance, you might be presented information like this if I had given you all the numbers, but most of the numbers don't matter. That's why I only gave you the 27. So let's see, let's go back to camera. So I might give it to you something like this. I don't know. Let's see. Hold on one second. That was number 11. Okay, so maybe like on the test, let me see if I can fix this. I might go like this. I might give you a little table like this. The face that has 1 dot on it. Let's say I tell you that, remember, this person is doing a repeated action, rolling the die 100 times and then collecting. How many 1s do I get? How many 2s do I get? Your question concerned 5s. Now, I didn't give you all these numbers because you didn't need it to answer the question, nor did you need it to pick out whether it was theoretical or empirical. The minute you saw repeated 100 times and collected the data in a table, automatically empirical. I did give you this information, that it was repeated 100 times, so you would know the bottom number for the probability. I asked you, what is the probability of rolling a 5? So that meant out of 100, how many times did you get a 5? So even though I only presented this number, that was the probability right there. Maybe on a test I'll give you all of them and see if you can pick out the right number. Like maybe I put a 15 here, maybe I put a 12 here, maybe I put a 30 here. Let me see if I've gone over yet. 57 plus 12 plus 15 plus 10. Oops. Help if my calculator is on. 57 plus 12 plus 15 plus 10. Okay, so that adds up to 100 different roles. I only was asking you about the 5, so that's really the only number that you really needed there was this one. But just the fact that it's repeated, that's what makes it empirical, and the fact that you're recording the data each time you do it. Okay, very heavily missed question on the test. Maybe put that on your note card. Okay, moving to next one. Okay, section 1.7, that's what we did today. Name the coefficient. There's no work for this problem. Coefficient is just 7. The base is the x, and the exponent's the 12. Given the number in standard form, convert to exponential. Given the number in standard form, convert to exponential form. So I started you off with this big long decimal, and you needed to move the decimal a certain number of times until you got it right in between the 1 and the 2. So that would be 1, 2, 3, 4, 5, 6, 7. Since this number started off being a number less than 1, this is a very tiny number. Seventh. You can show yourself moving the decimal as your work if you'd like. Okay, this one, expand 2 to the 5th and compute its value. The 2 is the number that is repeating, and this is how many times you're going to see it. The exponent says how many times it's going to repeat. So C was the choice. See, there's 5 of these, 5 of the number 2, and they repeat in the form of a product. Product means you're multiplying the repeaters. And so when you do that, you get a 32. Common answer, choice D. A lot of people choose that because they think 2 to the 5th means 2 times 5. Not a lot of people, but if you're doing it incorrectly, you're interpreting it that way. Okay, multiply and give the answer in scientific notation. We practiced that. So let me do that as my last problem where I review. Let me copy it first. You were trying to multiply 3 times 10 to the 12th. And we were trying to multiply 4.5 times 10 to the negative 3rd. Okay, so let me switch over to camera. Okay, there's the problem. And the last time we got together, we were practicing the rules for exponents. So there's 2 mathematical operations that we discussed, multiplication and division. And we said that whenever you're multiplying exponents with like bases, these are the bases, they have to be alike or you can't use this. Multiplying exponents, you're really going to add the exponents. That's the actual rule for taking care of multiplication, that you add the exponents. The coefficients, which are 3 and 4.5, you can handle those in the traditional sense. You're multiplying, so go and multiply them in your calculator. And the lessons notes packet talked about that, 3 times 4.5. And I did several demonstrations of this, that you use the calculators to handle the front numbers, which are called the coefficients. And then you use this rule for exponents to handle the exponents. So we're multiplying here. That's what parenthesis times parenthesis means. And when you add these exponents, it's 12 plus negative 3, which is the same thing as 12 minus 3. So you have this exponent. Then I'm going to read the question on Socrative one more time because it probably said put it in scientific notation, and that answer is not in scientific notation right now. Okay, so if you look at my answer, once again, Scientific notation, let me remind you, is when there's only one number, one non-zero number on the left of the decimal. There's too many. So if you only want one number, you're going to have to move this one place to the left. And in essence, what you're doing is you're taking this coefficient, 13, that used to be 13.5, and you're making it smaller by moving this decimal. So to compensate for the fact that you are making the true coefficient in this answer smaller, you need to make this bigger. How much bigger? And you can only make something bigger by adding to. You're only allowed to add in this case. Not that you can't make things bigger in other ways. How much bigger? Count up the spaces you moved here. If you moved one space, you're going to add one. If you had to move two spaces to get it in proper scientific notation, so that there's only one number to the left of the decimal, then you would add two. But I only had to move one space to get this coefficient perfectly in scientific notation, so I added one there. And now my answer is in full scientific notation. Okay, do you have any questions regarding anything that I've done here? I'm trying to review everything for you because your test is coming up. So today we will not do an activity, but I will teach you the last concept, which are called Venn diagrams. Also a sore spot for students. The sore spot would be not so much the set notation and what is a union and an intersection, but drawing a Venn diagram. That'll be an activity next time we get together, so pay attention to the diagrams that I draw towards the end of the notes. Okay, here we go. We're going to go over to the last section, which is section 1.8, and I'm going to give you some background on set notation and how to draw a Venn diagram. Venn diagrams are how we draw sets, particular sets of information. So let's just start from the beginning here. This is page 18 in the lessons note packet. If you printed it off, that's great. So very first phrase that you're going to fit in is it's called a set. We're studying sets in this section. And operations that you do with sets. Diagrams that you create having to do with sets. So a set is a collection of objects. They can be numbers, they could be words, they could be little pictures. It's just a collection of objects, or you could call them elements, or you could call them the members of the set, or you could call them the elements of the set, or you could say the objects in the set. Okay, typically we use little set notation. Like let's say that I wanted to put odd numbers from 1 to 5. There they are, right? Odd integers from 1 to 5. So the objects are numbers, and there's 3 of them separated by commas. Okay, let's see. So a set must be defined. In other words, its contents have to be clearly determined. And I guess they want the word well-defined, so let me not just put defined. We have to clearly know what is expected to be in a set, or else we can't create the set properly. So a set has to be well-defined. They have to really describe very well what they want in the set in order for you to properly create the set. So a well-defined set is necessary when you're doing set notation. Okay, the collection of the Academy Award winners. Now, I don't know who the Academy Award winners are because I don't watch that kind of thing, but that's not what they're asking here. What they're asking is that well defined? Sure it is, because you could get online and you could look up who are the Academy Award winners that have ever, anybody that's ever won an Academy Award. That information is very easily accessible on the internet. So is it well defined? Yes. The collection of the 3 best Academy Award winners. That is not well defined. And the reason that it's not well defined is because that's a matter of opinion. It's subjective. When something is well defined, it has objective parameters, very specific parameters. Here we know that the specific parameters are that it has to be someone that has actually been granted an Academy Award. Here, who's to say who the 3 best Academy Award winners are? One person is going to say, oh, it was these 3 people, they were my favorites. Another person's going to say something else. So that is not well defined. And you can maybe put the reason that's not well, because this is subjective. Subjective means it's a matter of personal opinion. That's what subjective means. So therefore, it's not well defined. Okay. Sets defined by superlatives or ambiguous adjectives are not well defined. Like the ambiguous adjective here is, who's the best Academy Award winner? Well, that's your opinion. And when it's subjective and it's your opinion, then that means it's ambiguous. The way you're defining this set, it's foggy. It's not clear. And the word for that is ambiguous, when something's not clear. So just some terminology coming at you. Okay, so the blank set or null set is the same that contains, the empty set. Another name for empty set is the null set. These 2 things mean the same thing. It's a set that contains no elements at all. How do we symbolize it? There's 2 different ways in mathematics you can say that your set contains no members, no objects whatsoever. You can either put the set symbols like this and leave it empty inside, or you can use this symbol just like that. Do not put one inside of the other, because if you go to give it like this, when you're trying to say empty set, and then you go and put this symbol inside of it, that is no longer an empty set. It's a set that contains a symbol. So don't do it like this. It's not a combination of the 2. It's one or the other when you want to say that it's the empty set. And you'll see when there's a reason to even use that as an answer as I go through the problems. I haven't gotten to the problems yet. Okay, what does this denote? What does this mean? This is the set. I want you to verbalize what this means. So write it in sentence form. This is the set, because these are set symbols, containing the number 0. You could say containing the element 0, containing the object 0. There's lots of ways you can write that. Okay, so that's not an empty set. It's a set containing one number. That number is 0. What does this describe? It is a set containing the element called the empty set symbol. Okay, so that's not an empty set. I just pointed out to that to you up here. All right, now we get into, now let me try and let you see more of the page here. Okay, so here we go into the kind of problems that you're going to be expected to do regarding sets. So the first thing that I want you to learn is this U, big capital U, symbolizes what we call the universal set. That would be everything inside this box. Now I want to teach you the definition of complement. That's this symbol right here. Another word for that is called, okay, so the complement. And then I'm going to define it for you. That's what all these words are for, so that you don't have to write them down. The complement of set A, symbolized like this. When they want to say that without writing it all out in words, they just put that symbol right there. So a little accent means the complement of set A. What does it really mean? It's the set of all the elements that are in this big set but not in set A. They can't be part of set A. So it'll be all the stuff hovering around on the outside of A. Therefore, if there's elements that are out here, those things are not inside there. They're on the outside of A. That's how you can describe complement in pictorial form. So like, for instance, if I wanted to figure out what the complement was by way of this picture, I would do the elements inside here first, and then I would put the rest of them out there. And the things that are floating around out here on the outside of circle A, because that circle right there stands for a set. They use circles or ovals, whatever you want to call them, to represent sets. Sometimes they're round, sometimes they're oval. So if you truly want to be able to answer this question by way of the diagram, not that you can't answer it without a diagram, but it's very easy to answer with a diagram. That means do the smaller set first. So there's A and there's D in this set. You don't have to separate them by commas. You can just put the A and the D in there. However, the universe that contains A and D is everything on the outside. So now to fill in the universal set means you want to mention everything that's in this set, but don't bother mentioning things that you've already mentioned, like the A and the D. If you've already mentioned them inside this inner circle, you don't need to mention them again. What's on the outside, also known as the complement, are the things that are not in A, but are part of this big granddaddy universal set. So let's see. I've already mentioned A and D, so I won't mention those again, but I will mention B, C, and E. B, C, and E. Put them anywhere you want. And these things that you are seeing floating on the outside, remember the definition of a complement. The complement of A are the things that are not inside set A. Elements that are not inside set A. We use capital letters when we're talking about a set. When we're drawing pictures of them, we use circles or ovals. So you can see that these are all the things that are in the universal set, but not in A. The answer to this would be B, C, and E. A complement is a set. So you give it in set notation, and you separate the objects that are, or the elements, whatever you want to call them, by commas. Okay, please stop me if there's anything that you need a different explanation about. Okay, intersection, you probably remember being exposed to these set symbols. These are, symbols that are that we go over every time we talk about sets. Intersection, this is the definition right here. What do the sets have in common? Now, when you have your set information, the objects that are in your sets, when you have them in picture form, like this is what you're seeing here. You're seeing set A. This circle represents a set. What does set A have in it? It has the number 14 and it has the number 8. And they numbered the regions, like everything that's out here, they called it region 1. Everything that's in the middle, they called it region 2. They just numbered these areas, and everything that's on the outer fringe of circle B, they numbered it region 3. But anyway, as far as the elements go that are in the set, set A has the number 14 and the number 8 in it. Set B has the number 8 and the number 13 in it. And then the things that are not in A and also not in B is the number 9. So this outer area here that's in the universe, but not belonging to either one of these sets, that would represent complementary numbers, and they called this region 4. Okay, so in this problem, they ask, what do they have in common? The number 8. This number 8 is part of set B, but also part of set A. So when you give an intersection, an intersection is a set. So give your answer in set notation. What do the two sets have in common? Just this one element. Union. Union is a set. Complements are sets. We did complements up here. The answers are sets. Union, intersections, and unions are set. Union means put everything You want to do everything that's in A, because you mentioned A, combined with B. They're telling you exactly what two sets to combine. They did not mention the universal set. That just means union. That means bring everything in set A together with set B. Okay, so let's put an answer. In set notation, the things that are in set A and B combined are 14, 8, and 13. You can put them in order if you want or not. It's everything combined, set A and B. And if anything repeats twice, there's no need to repeat it twice. But when you're in diagram form, if it does repeat in both sets, they're going to have it in this middle section anyway. Okay, sometimes you don't have a diagram. Sometimes you will just have two sets and you'll be asked to do either a union or an intersection. So you fall back not on the picture, because then you're making the problem too long, but rather on the definition. When it's upside down like that, that's called the intersection symbol. This means what is the intersection of set L and H? And that is defined as what do they have in common? Okay, and this might be nothing. It might be they have nothing at all in common. Let's see, they don't both have a D, they don't both have a G, they don't both have a J. There's no A's in here, there's no H's in here, there's no K's. They have nothing in common. That's your answer, the empty set. So now you see the use of the empty set. You can give the answer like that, or you can give your answer to this particular problem, what's the intersection? You can also give it like this, that they had nothing at all in common. When it says what is the union, that means put everything together that's in set L and H. So that would be A, D. You don't have to put them in order, in alphabetical order here. H, J, and K. Okay, that's all four things. All 6 items in the same set. Okay, moving to the Venn diagrams. This is the thing that students have a little bit of hard time with. So I have tried to make what I want you to do very, very obvious. When we draw Venn diagrams, you must always start by filling in the middle section first, because the middle section, the things that you put in the middle section will affect what you put in these outer sections. They will definitely impact them. So make sure that you always address the middle section first. What is the middle section for? Let me repeat from the previous page. It's what these two sets have in common. This is where you put the common element, what we call the intersection. Okay, so it says, let's label things. I'm going to read up here. We surveyed some customers and obtained the following results. 20 people ordered Rocky Road ice cream. 30 people loved the salted caramel ice cream, and 5 people liked both. Okay, here we go. Got 2 circles because there's 2 ice creams that they're talking about here. There's Rocky Road. We'll let this circle stand for the Rocky Road. We'll let this circle stand for salted caramel. And then we can start putting the numbers in. So it says, let's go back and read again. 20 people ordered Rocky Road. 30 people love salted caramel. And a lot of students, the ones that get it wrong, is because they don't pay attention to this. You are not to put any numbers in this picture unless you do the middle number first. And that's going to be this right here. 5 people like both. Look for the word both, or what the common elements are. They'll usually use the word both. So there's 5 right in here, and those 5 people like Rocky Road and they like salted caramel. But this 5 impacts what you're going to put right in here, and it also impacts this. Because if you go back up to these numbers, you see how it says 20 people liked Rocky Road? Well, this is already 5 of them. You don't go and put a 20 out here. You have to take 5 away from 20. And you can show that or not, but I need to see a 15 in there. Okay, I'm just putting right here where I got that from. Go back up to the reading. It says 30 people loved salted caramel. Well, here's 5 of them right here. These people like salted caramel. You can't count them twice. So if 30 people total liked salted caramel, only 25 should go out here. And you can read these results once you get done with them. 15 people liked just Rocky Road. 25 people liked just salted caramel. 5 people liked both. Okay, checking your answers. 20 total for Rocky, 30 total for salted caramel. They can make you answer different questions off of these diagrams. Okay, that's constructing your own Venn diagram. A little bit of an issue. Okay, let's practice again. Here's one more. I might have to get cut off at this point. And if I don't finish these, then I'll do them next time, but I'm going to try and finish. Okay, so A, B, C, D, and F. Let's see, what do we have here? So what you could do here, now they only want you to use, okay, so they give you a universal set. They give you Y and Z. And you're going to do the universal set as well. Okay, so first of all, let's see if, since Y and Z are the sets that they have labeled here, let's go and see if they have anything in common. So I'm looking at these 2 sets here, and I noticed that they both have an E. Remember, I was telling you to do the common items first. They both have an F. And then let's see, they don't have anything else in common. You must do the common elements first. That is what causes students to get this drawing incorrect. And this is going to be asked on the test and in ALEKS as well. So go right in here, put things that they had in common in the middle region. So I did my middle region first. Okay, then I can go and complete these circles. Let's finish Y. Besides the E and the F, which I've already stated for Y, there was a C, an H, and an I. C, H, put them anywhere you want. Then in set Z, besides the E and the F that I've already mentioned, set Z also had a B in it. Okay, then it's time to do the universal set. The universal set is the numbers that go inside this box, but you're only going to mention out here on the outside of the circles, the stuff that hasn't been mentioned yet. So like for instance, in you need to mention somewhere in this big universal set, A, B, and a C. Let's see if I've mentioned those yet. A hasn't been mentioned, so put that out there. Then there's the letter B. B's already been mentioned, so I'm done with that. C's already been mentioned. D has not been mentioned, so it goes out here, floating in the universe. The letter E, that's been mentioned. F been mentioned. G has not been mentioned. H has already been mentioned. I has not been mentioned. And that's how you construct the diagram. Do the common elements first, then put the remaining items from Y. You already had 2 of them here. Then put the remaining items from Z. You already had 2 of them there. So you got everything in Z, everything in Y, and then go and look what's here. Compare it to the universe. These would be the letters that haven't been mentioned at all yet. They're just floating around on the outside of sets Y and Z. And I don't know what that little picture is about, but that's the diagram all finished. Okay, let's go to the last page here for section 1.8. How many elements below? And I think that was a typo. I think this is belong. So fix that. How many elements belong to set A? Okay, there's this here. They're just numbering the areas here. So the elements that you see here that belong to set A is this number that's in the circle A and says 8. So the answer to this is there's 2 elements. They don't want you to name the elements, so you don't say 14 and 8. You count up how many elements there are. This is 1, this is 2. Okay, which regions represent set E in the Venn diagram? The regions that are set E. Okay, this circle. Circles stand for sets when you're drawing a diagram. So the regions that are in set E are 2, 3, 5, and 6. 2, 3, 5, and 6. You don't have to put those little legs there. Okay, so then in number 3, one more one more attempt at drawing our own Venn diagram. Don't forget, we're going to put middle region first. So let's read. There's 565 students taking either algebra or quantitative reasoning. 327 are taking intermediate. 266 are taking quantitative. And they want us to do, and 28, always look for where it says both. So that is what you're going to put in the middle region first. Okay, that goes in the middle, and then it will affect how we report the 327 and the 266. So you're going to put 28 in there first. That 28 that you put in the middle impacts the 327 as well as the 266. Maybe put that in your notes so you're not one of the people that makes that mistake. Okay, so now let's see. There is one set of people that took intermediate algebra. There's another set that took quantitative reasoning. Okay, so right in here let's see, there were 327 people taking intermediate algebra. So I'm just going to go 327, take out these 28 people because these 28 people are taking both classes. And you've already counted them as part of the people that are taking intermediate algebra. So that's just me showing my work. Take out the 28, you get 299. Then right here there were 266. Take out the 28 that have already been accounted for. Total of 565, so that you can put the remainder of the people in this universal set. So let's see, so far you've accounted for 299, don't say those again, the 28 in the middle, subtract that out, and the 238 on the outer fringe. Subtract all these numbers from 565 because they've already been mentioned in here. And you get, let's see, that is 565 total. That means that I don't have any floating in this outer rim. I was going to see if there was any left over, but that takes you to 0. So 299 plus 28, let me just check that again, plus 28 plus 238. Yep, that accounts for all 565. So if there was a number down here, I would put those remaining from the total universal population. If there were people remaining, I would float them out here, but there weren't any, so I didn't have anything left to put in there. Okay, that concludes the lecture for section 1.8 and concludes the whole chapter. If you have any questions, I am tutoring for several hours. Please look at my tutoring schedule, but I believe I'm online giving virtual help from 11 all the way to 1:45. Those are my office hours in the afternoon. I'll be on again tonight, I believe from 6 to 7:15. I don't have my schedule right in front of me, and I'll send out a link and an announcement. Everybody have a beautiful day, and maybe I'll see you in tutoring. Bye-bye. You're welcome, Alexis.